Derivatives. The definition of derivative. The process of finding the differential coefficient of a function is called differentiation from first principles, and the function so obtained is called the derivative or the derived function. Meaning to say, to differentiate a function is to find its derivative. If y is equals to f of x, then we can say that dy dx, which can be written as f prime of x is equals to df dx. Note that dy dx is called the differential equation. It's called the differential coefficient. Of y with respect to x. That is derivative. Here, we can also define derivatives as a rate of change. We can define derivative as a rate of change. The derivative of a function at a particular point tells you the rate at which the function's value is changing at that point. If you have a function f of x, the derivative f prime of x is dy dx. That represents the instantaneous rate of change of f with respect to x. It can be represented as the slope of the tangent line to the graph of the function at a given point. For example, if f of x represents the position of an object over time, then the derivative f prime of x is dy dx represents the velocity of the object at the time x. The derivative is defined as the limit. So we can define derivative as the limit f prime of x is equals to limit of f of x plus the little increment h minus f of x divided by h as h tends to 0. This is a limit, and that is the definition of derivative. Right? Example. Let's have a look at this example. Let x of t denote the distance traveled by a moving object in st seconds. Let me write you something. Let s of t denote the distance traveled by a moving object in t seconds. Then the instantaneous velocity after t seconds denoted by the t, the s, the t, or we can write it as s prime of t is given by ds dt equals to limit as the t approaches 0 equals to change in distance over change in time. Change in time. All right. This is equal to limit as ds dt approaches 0 s t plus h minus st over dt. All right. Therefore, velocity is the rate of change of distance with respect to time. I hope we are together. This is clear. Just play the video twice and you understand quite how it goes. This is another definition, another way of finding the derivative of a function. Please don't forget to like it, subscribe, and hit the notification bell for more tutorials. I'll be coming your way more examples on limits and derivatives. Thank you.